Okay, so welcome back, and now we're going to start defining approximations for the area of the curve, and we're going to start with what's called the left endpoint approximation. So what we're going to do is we're going to use rectangles to approximate the area under the curve. Okay, so we're going to have a certain number of rectangles and so on. So let's start with the idea of how we're going to approximate the area. So again, we're going to subdivide into subintervals, right, based on how many subintervals we want or we're told. And then what we're going to do is we're going to construct the rectangle. So there's a couple of different ways we could, well, a few different ways we could construct the rectangle. One way is to use the left endpoint of the subintervals. So the first left endpoint would be x0 for x0 to x1. And then we take the subinterval from x1 to x2, so we would use the left endpoint of that one, which would be x1, and so on. So what we're going to be doing is in the subintervals, we're going to use the left endpoint to find the height of our rectangle. So we're going to construct the height of the rectangle based on the left endpoint of each subinterval. We already know what the width of the rectangle is going to be. It's going to be delta x. Okay? And so each one of these widths is going to be delta x all the way down. And then the height of the rectangle is going to be based on the left endpoint. So the height of the first rectangle is going to be based on where this x value is. So we're going to base it off of this height. Okay? And then the next subinterval, okay, right here, we're going to base it off of this value, so the height of the rectangle will be there. And then for the next subinterval, we're going to use the left endpoint here to get this height, and then so on. And so then we get this view, or this visual of the rectangles. Notice that the height of the rectangles is always on the left, because we're using the left endpoint. So here's the rule, okay? This is the left endpoint approximation. Okay, rule number 3, on each subinterval from x of I minus 1 to x of I, for I equals 1 to n, we're going to construct a rectangle with a width of delta x. Again, how do we get the delta x? Well, delta x is just equal to b minus a over n. Okay? And the height of each rectangle is going to be f of x of I minus 1, the left endpoint. So it's the function evaluated at the left endpoint, which is the function, well, which is what I just said. Then the area of the rectangle is going to be f of x of I minus 1. So it's going to be the height of the rectangle times the width. That's going to give us the area. And then adding these areas for all of the rectangles is going to give us an approximate value of the area A, which is the area under the curve from A to B, on the interval AB. Now, we use the notation L sub n to denote a left endpoint approximation. Okay? So, we would say the area of the curve is approximately equal to L sub n, which is equal to f of x0 times delta x plus f of x1 times delta x all the way to plus f of x sub n minus 1 times delta x. And of course, we can use the summation notation, which gives us this. The summation for I equals 1 to n of f of x sub I minus 1, so there's your left endpoint, times delta x. And that is how we do a left endpoint approximation. Okay, so next time we're going to actually show right endpoint approximation, which is very similar to what I just did, except what? We're going to be using the right endpoint of each subinterval instead of the left. See you then.